Now everybody, let's go to the question number 4. A person is moving in a straight line. The person will be moving in a straight line. The speed of the person at point A is 10 meter per second. Speed of the person at point B is 20 meter per second. Speed of the person at point C is 30 meter per second. And speed of the person at point D is 40 meter per second. Great. Now we have to tell about the motion of the body, okay, or the person. Now here we can see the speed is increasing continuously. Here is 10 meter, then it is 20 meter, then it is 30 meter, then it is 40 meter. That means it is confirmed that it is not uniform speed or it is not uniform velocity also. That means velocity is increasing, okay, and all are the speed or velocity are the instantaneous. It is the instantaneous velocity over here, it is the instantaneous velocity over here, it is the instantaneous velocity here, it is the instantaneous velocity here, right? So all the velocities are increasing. So my first conclusion is it is not uniform speed or uniform velocity. Uniform velocity as the value is increasing continuously. Okay, we can see here. Now that means body is in non-uniform motion, as speed is not uniform and velocity also not uniform, so it is in non-uniform motion. Now let's check the acceleration is uniform or not. So to check the accelerations, first take this difference A to B, the change in velocity and in the time difference. Okay, here the velocity 10 meter per second was the initial. After 2 seconds at B point, the velocity was 20 meter per second, right? So we will do the acceleration now. Acceleration from A to B will be change in velocity, because acceleration we know rate of change of velocity, so change of velocity divided by time. That means from A to B the acceleration change will be 20 meter per second minus 10 meter per second, and the time taken is 2 seconds. So acceleration is this much meter per second square. Now 10 by 2 meter per second square, that means 5 meter per second square. Okay, so from A to B the acceleration is 5 meter per second square. Now from B to C, what is the acceleration? Now let's find out what is the acceleration. So from B to C the velocity changes from 20 meter per second to 30 meter per second in 2 seconds. Okay, so change in velocity by time, So what was the final was 30 meter per second, initial was 20 meter per second, time taken is 2 seconds. So this much meter per second square. So 10 by 2 equals to 5 meter per second square. Okay, no problem. So in B to C the acceleration we also find out 5 meter per second square. Now we are coming C to D, right? So C to D, what is the velocity difference? Here is 30 meter per second, it becomes 40 meter per second. So change in velocity again 40 minus 30 is 10, and how much time gapping? Here is also 2 seconds. So acceleration is 40 minus 30 by 2. So it will become 10 by 2 equals to 5 meter per second square. So from C to D also we see the acceleration is 5 meter per second square. Okay, so do you have any idea that acceleration is a vector quantity? So it has a direction, and which direction accelerates is towards? It is from A to D, because velocity is from A to D. Velocity is this direction because the body is traveling in this direction. Also the acceleration is from this direction. At every point the acceleration is at this direction. It is a vector quantity. Okay, now I have to consider, is it a uniform acceleration or non-uniform acceleration? So students, it is a uniform acceleration. How I have understood? Because the value of the acceleration is not changing, and also its direction is not changing. It is in direction this side. So what we can say? Motion of the body is accelerated, and the acceleration is uniform as value and direction of acceleration is not changing with time. Direction is from this, in direction is also this direction, and values are every time 5 meter per second square.